Okay, let's go ahead and look at our third example here. Here we're going to graph y is equal to x over x squared minus 1. And this is going to look an awful lot like the last one that we did. But notice instead of being 1 over x squared minus 1, I put an x over x squared minus 1. And let's see how this changes things. We'll start by looking at our vertical asymptotes. Remember, that's where that denominator would be equal to 0. And again, we have the same exact situation we had in example 2. So we get x is equal to plus or minus 1. Two separate values for this. As far as horizontal and oblique, we do not have any oblique because, again, we can't do a long division. We're going to look at some, I promise you, when we come back to class after Labor Day on that Wednesday, that will include some oblique asymptotes. We haven't had any yet, but we will, and I did an example in class. But we do have some, it may have a horizontal asymptote. Let's look and see if it does. In a horizontal asymptote, we let y be equal to the limit as x approaches positive or negative infinity of our function x divided by x squared minus 1. And again, if I just plug in infinity here, I'm going to get infinity over infinity. So let's come through and divide by the highest power of x, which is going to be an x squared. And once we do this, remember that anything that gets stuck or that winds up with an x in the denominator, when it's all said and done, is going to go to 0. So this is going to turn into a 1 over x, which will become a 0. This is going to stay a 1 over x squared, which will become a 0. And this term here will actually just become a 1. And I get 0 over 1, which is 0. So once again, we get y equals 0. And again, you will not have any oblique. Now, when you're doing this work, I'm expecting you to do the same thing that you're seeing me do. That is, show me that you're looking at all your asymptotes. The next thing we need to do, and I need to see this in your work, is we need to determine if it crosses the horizontal asymptote. So let's determine if it crosses. In order to do that, we're going to take our horizontal asymptote, which is y equals 0. We're going to plug it back into our original equation. And if we get a value for x, then what that says is, yes, we will indeed cross, and that'll give us the ordered pair at which we cross. So we're going to let 0 be equal to x divided by x squared minus 1. Once again, I'm going to go get rid of these fractions by multiplying both sides by x squared minus 1. Of course, 0 times anything is 0, so I get 0 on the left. Here these cancel out, and I get x equals 0. Perfectly valid value. So we see that here's an example where we are actually going to cross this thing at the ordered pair 0, 0. Let's go ahead and put this information on a graph. Okay, let me start by, once again, putting some marks on here. And since I know that the area that I'm dealing with is pretty much right in here around the x equal 1 and negative 1 and the y equals 0, I'm just going to kind of shrink this up a little bit. I'm going to let every 4 units be 1 on the x-axis and every 2 units be 1 on the y-axis. And we're going to come in here and we're going to start again by putting in our asymptotes. And we've got the same thing as we saw last time. We've got an asymptote at x equal 1, at x equal negative 1, and at y equal 0. However, this graph is going to cross this asymptote right here at the point 0, 0. I get that in a black color here. It's going to cross through that graph right there at that point. Let's see if there's any other information we can get. We're going to come back and look at this graph, but let's go ahead and see if there's any other information we can get, including things like intercepts and symmetry. So let's go back and look at that. We saw that because we saw that that was a place that the graph crossed that horizontal intercept. So there are going to be 3 sections to this graph once again, as we saw before. There is this section on the left, there is this section on the right, and there's a section in the middle. Now, since the graph crosses right there, there is one of 2 things that can be happening. Either it's going to come down from hugging this intercept, go through the center, and come up and hug this one, or it's going to come down in this direction, hugging that intercept, and go down in this direction. And we just need to figure out which one of those things is happening. I know that it has, well, and actually that's not the only thing that could be happening, is it? It could also And I'm saying that's the only thing, but that's not the only two things. It could also be doing something like, let's see, let me put that region back. It could also be doing something like this, where it does this. Or it could be doing this. I'm not exactly sure what's happening. And how do I figure that out? Well, it's not real difficult. In order to figure this out, let me get rid of some of this garbage so we can work in here. In order to figure that out, what I'm going to have to do is I'm going to have to pick a point on this side and see what's happening on this end of the graph, and I'm going to have to pick a point on this side and see what's happening on that end of the graph. And remember, when we get our points, we're going back to our original equation here, x is equal to x squared minus 1. Well, I'm going to need a point in between 0 and 1, so I might try x is equal to 1/2. Now, you're welcome to take out your calculator and put that in if you want, or use decimals. That's no problem because I'm not looking for the actual answer here. You need to figure out where it is so you can figure out what this thing is doing. So if I put in the 0.5, that's what you prefer, and 0.5 squared minus 1, let's see what that gives me. If I plug this in the calculator, it gives me approximately negative 0.375. Now remember, you're not turning that into me. All you're doing is graphing that thing. So it's coming down in this direction, and that tells me that I'm going to be hugging. Let me get a little bit darker color here so we can see this graph a little better. That means we're going to be hugging this axis as we go down in this direction. And then I'll pick a number on the other side of that, between the 0 and the negative 1. For example, y is equal to a negative 0.5. And when I put that in, I do believe, and you can double check me on this, that you're going to get a positive 0.375. So what you'll see on that side is you're coming up in this direction. And then we just need to figure out what's happening on the two ends. On the left-hand side, remember, it's not going to cross there. The only where it crossed that horizontal axis was in the middle. So either my graph is going to do this or it's going to do this. Likewise, on this side, same thing. It's either going to come up in this direction or it's going to come up in this direction. Because, once again, it is not going to cross the asymptotes on these two ends. It only crossed in the spot we found, because if it would have crossed somewhere else, we'd have found it. Okay, so if you put in, for example, x equal negative 2, you're going to wind up getting a negative 0.6667. So we can see that the graph on this end is going to give us this kind of graph. And then if I pick a value like x equal to 2, I get a positive 0.6667, which actually puts it over in this direction. Or what we started out with was y is equal to x over x squared minus 1. Okay, if you try for symmetry on this, what you're going to wind up with is no symmetry at all. Again, I'm assuming that's something you can do. That's a very easy algebra technique. But we can look for the intercepts. And for intercepts, we can start by looking for the y-intercept by letting x be equal to 0. And if I let x equal to 0, I get y is equal to 0 divided by 0 squared minus 1, or the ordered pair 0, 0, which we already had, and we knew that it was a point on the graph, and we'll look at how it's an intercept in a minute. And then we can also let y be equal to 0. And if I let y be equal to 0, I think we already did this one, didn't we? Let's see if I put the right thing in here. It shouldn't be 0. It should be 0 for y. 0 is equal to, sorry about that, x over x squared minus 1. We just did this, right? Multiply both sides by x squared minus 1, and we get x equals 0. So the only intercept we have is the one where we're crossing in the middle of this graph.